Okay, it's 2 p.m. We're going to start the webinar. Hello, everyone, and welcome to today's webinar on aluminum repairs. Are you ready? Presented by ICAR and hosted by IMPACT. If there are any audio issues today from GoToWebinar, which we don't anticipate, we have a backup plan. I wrote an 800 number in the bottom right hand of your screen. It's 800-410-3590, and you type in passcode 9786917#, and that's our own conference number, and we could resume, but we don't anticipate anything happening today. I'm Melissa Joles with Impact Collision Solutions. Jeffrey Poole, Performance Training Coordinator with ICAR, is your presenter for this webinar. The presentation will take approximately 45 to 50 minutes, and we are recording it, and we'll post it on the website under Training Videos. If you have any questions, you can type them in the chat box at the bottom right of your screen, and Jeff will answer these at the end of the presentation. Okay, I'm going to turn it over to Jeff now.
Thank you, Melissa. I appreciate it. I'd like to thank Impact Collision Solutions as well for hosting the webinar here today. I'm Jeffrey Poole, Performance Training Coordinator with ICAR. As we kind of take a high-level look at this presentation, I'd like to give you hopefully a better understanding of what it's going to take to repair an aluminum-intensive vehicle structure. We'll look at some of the design elements of the vehicles. We'll look at some of the attachment methods of the vehicles. We'll look at some of the part replacement criteria of the vehicles that are out there. The vision statement of ICAR is that every person in the collision repair industry has the information, the knowledge, and the skills required to perform complete and safe and quality repairs. This is for the ultimate benefit of the consumer. I think it's really critical that we keep this in mind as we look at repairs, especially on today's vehicles, where the design and engineering of those vehicles is so much better than we've seen in past decades. Definitely some strategic engineering going on there, and with the introduction of more aluminum in the vehicle structure, there's still a lot of strategic engineering going on there. I think it's no secret. Aluminum use, yes, it is on the rise. I believe most everybody out there is aware that Ford for 2015 is going to build the body, the cab and the bed of the F-150s of aluminum. And so what we look at in this particular presentation is kind of a generic view of repairing aluminum and working with aluminum, but a lot of what you're going to see here, you're going to find that there's elements of it that are applicable to that F-150. We'll talk a little bit more about some F-150 specific training towards the end of the presentation. Basically, for us to have a good understanding of what we're dealing with, we want to kind of understand aluminum better as a metal. Now, whenever you hop on an airplane and you travel someplace, you hop on one of those Boeing jets or one of those Airbus jets, and unless you're on one of the really modern one that has the carbon fiber and all that good stuff, predominantly we're dealing with aluminum structured aircraft. And aircraft have been put together with aluminum and rivets for a lot of decades. Throughout the evolution of aircraft, they have transitioned from just aluminum and rivets to, in many cases, structural adhesives and rivets holding some of those aircraft together. So this is not something that somebody just thought up and said, wow, let's try this. This is tried and true for many, many decades. In the past, we've seen the aluminum structured vehicles really just being the Audi A8s and the high-end Jaguar aluminum structured vehicles and things along those lines. But again, with the introduction of 2015 F-150, we're going to see it out there in a much bigger volume than we've ever seen it before. My hat's off to the folks at Ford for taking that step. So it is lighter. Ultimately, that's what we look at in that primary weight savings. There's also kind of an indirect weight savings. As you lighten up the vehicle, you can make other elements of the vehicle lighter as well. So it's kind of a twofold effect there. Aluminum does have good collision energy management. It has good strength characteristics as we kind of think about it in comparison to steel. Now, aluminum doesn't meet the strength levels of ultra high strength steel, so there's still going to be certain parts of the vehicle body structure in many cases where they may introduce a little bit of ultra high strength steel for additional reinforcement purposes, but aluminum is a top performer. Absolutely, it is strong. A lot of the aluminum alloys out there, they really meet and fall into some of the same strength category ranges as some of our dual-phase, multi-phase, and high-strength steels that are out there. And so that gives us a good comfort that these alloys will have the strength to perform the functions required on vehicles out there in daily use. We're going to transition and talk just a little bit about whenever a vehicle body structure comes together, what are the different manufacturing methods that they take and make the different parts. One method they use is called a casting, where they actually take and they have some sort of a sand mold or some other mold where they'll take and pour the molten aluminum in and then take and cast that part. The next manufacturing method we'll take a look at is going to be extruded aluminum, and that's if any of you've got kids or grandkids or other relatives out there that maybe play with the Play-Doh Fun Factory, where they take and they put the Play-Doh in and then they press the Play-Doh out through it and it makes the different shapes. That's essentially what the extruding process is, and that tends to make tubular structures, if you will. Now, it doesn't have to be round. It could be any given shape that is kind of an enclosed shape as it is over its length. And then we have stamped aluminum parts, which are very typical of what we're used to seeing in body structures on vehicles that are steel structured, and that they take and they have the dies that they take and press down tremendous force and takes and stamp the part out of a piece of sheet metal, sheet aluminum in this particular case. So we'll take a little closer look at each of those. Now, stampings are predominantly what we see out there on most of our aluminum structured vehicles, and that's what you're going to find even on this new contender that's coming to the neighborhood real soon, is that predominantly the aluminum structural components in that vehicle are stampings. So we'll find that there's sheet metal parts with the attachment flanges and things of that nature. We're going to find that in many cases those parts are rivet bonded into the structure of that vehicle. In some cases in the past, we've seen some resistance welding going on, and you're going to see very limited applications of resistance spot welding on aluminum structured vehicles. It takes a tremendous amount of current to do resistance welding on aluminum, and so they tend to limit that to areas that are uniquely qualified to need that application. So stampings are our first. The next one is extrusions. Here we have a host of extrusions, except the yellow, red, and green component. The yellow, red, and green component is a steel rocker panel cross-section. Now, the reason we have that on there is just to kind of give you a comparison, if you will, between traditional steel construction, where we would have an outer rocker panel, we would have perhaps an inner reinforcement, then we'd have an inner rocker panel, and then we take a look at the other three pictures on the screen, and we see three different extrusions there that have, two of them have inner walls. The upper right-hand picture is actually a Corvette frame rail, and that's a hollow extrusion on that particular one. That's representative of the ZR1Z06 in past years that had the aluminum frame in it. So as we look at that extrusion, especially the two bottom photos where you've got the internal walls, this is where it's really important to understand that as that part is manufactured, it comes out of the manufacturing process looking like this. Think about what happens whenever this part gets damaged. Now, if you had no internal walls, then perhaps that part could give, and there may be some limited opportunities to repair it. Now, we start getting those internal walls, that's going to, in many cases, limit what we can do with that part in the realm of trying to straighten or repair it. So, again, having an understanding of how that part's made and what the applications are, it's not unusual to see extrusions in rocker panels on some vehicles out there, perhaps an A-pillar tube or a front fender rail reinforcement tube or something of that nature. It really depends on what the engineers and the vehicle manufacturer were looking for in the performance of that part. Something else you're going to find about extrusions is that you may have some allowances out there from some manufacturers to section some of these. Generally, they're going to give you some specifications or guidelines on where that's applicable. In other cases, they may flat out say, due to the nature of that part and the critical strength characteristics of that part in the application, they don't want you to section it. So it's really going to be critical that no matter what vehicle we're working on, that we're looking at the most current and up-to-date service and repair information for that particular vehicle. I think as an industry, that's something that we really need to take seriously as we look at vehicle repairs, to ensure that, number one, we do have the right information, the right repair procedures that we're following, but that we're also supplying that hopefully to the technicians that are doing the work, so that they can then apply that to the vehicle that we're working on. So castings. Castings are something that have been around for a while, and we've seen a few vehicles out there, and Cadillac has a cast strut tower, and there's a number of other vehicle manufacturers that use castings in various different locations on them. I will say that the new kid on the block, and I say that affectionately, does not use any castings in the body structure whenever it comes to the cab or the bed. Who knows what we'll see down the road on other vehicles, but the castings, again, are typically parts that there's some sort of a mold, and they take and they pour the molten aluminum in, and they may do vacuum die casting and things of that nature to give it greater integrity and minimize any type of air pockets or flaws in the casting. But castings, they're typically rivet bonded into the adjacent structure on the vehicles where they're used. We may have limited applications where they use welds, but again, most popular that we see out there in construction is rivet bonding. And so you'll find that castings kind of have an irregular surface. They may have machined areas where parts attach bolt on and things of that nature. I've seen some of the castings out there that actually are so finely made that you can't really tell it's a casting until you get up really close to it and look at it very, very closely. So again, close inspection and service information can also help you understand and identify what we're dealing with in castings. Now, castings present kind of a unique challenge for us. Casting is typically something that's very rigid. The alloy that it's cast out of, it's made out of, doesn't tend to give. At the point where it gives, it usually fails. And I say that carefully, but it's very important whenever you're dealing with any structural parts on vehicles that we're doing a thorough inspection, as we look at the characteristics of, I'll say, the malleability, how much a part will give before it bends or breaks. Castings tend to not be very tolerant of movement in that regard, and so they tend to be rigid parts. Where the structure moves, you may find that the castings start to break loose, or the rivet bonded joints are compromised where they attach in the adjacent structure. Again, thorough inspection of the vehicle structure. If you had something with a side sway on it at a cast strut tower, you'd want to look really closely at all the attachment perimeter areas of that casting to the adjacent areas of that vehicle, along with any other structural components on that vehicle. So just something to think about. Galvanic corrosion. So as we think about the prospect of having a very high volume vehicle out there on the road, and we think about the prospect of that vehicle showing up in our shop, we have to think about what happens whenever you get steel and aluminum together and you have some sort of an electrolyte, road salts, road chemicals, water that's not pure, and we don't have too much pure water in the environment. So as we take and we then bring the chemistry together, and that's exactly what's happening whenever we have steel and aluminum coming together, and we have an electrolyte. We've got a chemical reaction going on. It actually creates a small galvanic battery, and electrons start to flow. Very, very small amount. What that does, though, it starts to erode the metals. And aluminum doesn't corrode quite the same as steel does. Steel and iron take, and they give us that red rust that we're so used to seeing. Aluminum tends to kind of give us a white ash, powdery type substance that is then the corrosion, and that starts to pit and degrade the aluminum at those areas. So galvanic corrosion is something that the vehicle manufacturer know exists. They know that this is a reality in the manufacturing processes of the vehicles. They take the appropriate steps that they feel are prudent to take and minimize any galvanic corrosion issues that are out there. It's going to be important for us as we're working on these vehicles to understand galvanic corrosion and think about what we need to do to minimize any issues. We may find that most of the vehicle manufacturers that have set up repair guidelines for their vehicles, they require, I'll use the word recommend, they require you to have some sort of a clean room. Now that doesn't necessarily mean that it has to be a totally separate building. Perhaps it's a curtain wall That's what some of the vehicle manufacturers look at, is having some sort of a curtain wall. That way, if I'm working on a steel vehicle and then the next stall over and I'm grinding and I'm throwing sparks, I'm not throwing it right over there on that aluminum vehicle. So this is, again, an area where we want to minimize cross-contamination issues in that clean area of the shop where we're going to do those repairs to the aluminum aspects of a vehicle. We would have some sort of an appropriate dust collection system to help minimize the aluminum dust, which is going to tend to remain suspended in the air and circulate in the shop and perhaps cause other cross-contamination issues. We'd want to have dust collection to take care of that. That would be a prudent move. Sometimes it comes right down to just some good housekeeping practices. I know in many cases, and I was guilty of it for many, many years, whenever I was working on vehicles, I'd get my air blower out and I'd blow the dust and dirt off of the car. And heck, a lot of that stuff went into the air, and not really thinking too much about it. Maybe there's some habits there that we should change as technicians too. Just a thought. So galvanic corrosion is something that they take and they minimize by ensuring that these metals don't touch. Perhaps there's coatings in between the metals, specially coated bolts and things of that nature that we'll talk about as we get a little bit deeper into the presentation. Work hardening. So aluminum tends to have a little different response to forming and damage. As they take and they stamp a fender, for example. And that fender goes from being a piece of sheet aluminum, and it gets stamped, and that work hardens. Steel does the same thing. It work hardens where they have the tightest form lines and things of that nature. But aluminum tends to be a little more stubborn. So aluminum gets work hardened, it gets manufactured, it gets stamped, and so it's work hardened some. Then it gets in a collision, it gets work hardened some more. Now we get in there and we start to repair the vehicle. We may find that the limits of repairability are perhaps a little different than we were used to with especially our mild steel. Mild steel was very forgiving. Some of the high-strength steels today are a little less forgiving than they are a lot less forgiving than the mild steels. Perhaps you get bake-hardened steels out there that present some interesting challenges to us as they do respond a little bit differently. But aluminum tends to put itself, I'm going to say, above all in being less than cooperative whenever it comes time to take and let's get it to go back where it was. It's that work hardening. That molecular structure is now locked into that new damaged form, and we need to be very strategic in our attempts to remove it. We can't overwork the metal. Well, we can overwork the metal, but we don't want to overwork the metal. So we find we have to be a little more strategic in our structural realignment operations or cosmetic repairs so that we minimize the chances of causing that panel to crack if it hasn't cracked already. That's one aspect of aluminum panels that we're going to find there's going to be a learning curve for a lot of the industry. I try to encourage technicians especially that if they've got a hood or one of those rear gates off of one of those SUVs that's aluminum or some other aluminum part that's headed for the scrap pile. And I know sometimes it's challenging to take some time and get together with your associate technicians out there. But maybe take that part that's going on the scrap pile and experiment with it a little bit, work with it a little bit. You'd be surprised some of the things that you can probably do if you're not under the gun for time so far as that goes. And I know with production shop situation, what that does for us in our desire to get work done and things of that nature. But there comes a point in time where we will have to expand our repertoire of tools in our toolbox, and that means our skills, not just our hammers and dollies. So work hardening is something that we're going to have to contend with. Heating considerations. So I have to put the disclaimer out there. Always follow the vehicle manufacturer's recommendations and guidelines for heating any part on any vehicle, whether it's aluminum or whatever else it may be. Again, there's a huge amount of concern about the structural integrity, future crash performance of vehicles, and whatnot. In most cases, I say that carefully, in most cases, vehicle manufacturers have some allowances there for perhaps doing some minor heating on aluminum components. There's a couple of manufacturers out there that say don't do it. So again, check with the OEM guidelines in all those cases. But where heat comes into play, aluminum doesn't tend to be as critical on heat for time. It is very critical when it comes to heat for temperature. And we have to make sure that anytime we are heating an aluminum part during the repair process, we understand what's happening to that heat and what's happening to that part. Obviously, the heat goes in, it starts to propagate, it starts to migrate, and heat travels very quickly in aluminum. If there's a bonded flange anywhere close by, it can degrade that adhesive in that bonded flange area very, very quickly, so we have to be very cautious. Generally, whenever we start looking at using heat in order to encourage an aluminum part to be more cooperative during repairs, and that's really what we're doing when we're applying the heat to aluminum, is we're going to take and we're going to warm it to get those molecules to be a little more cooperative. We're not getting crazy with the heat. Typically, we're looking at 400 degrees, 425 tops. There may be some allowances from a few manufacturers to go a little higher than that, but that starts to get very uncomfortable. I know some aluminum technicians out there that they've had great success with the 350 range, and generally if you're 350, you're probably starting to peak at 4 where your heat's going on that panel. So we have to be real careful there. So as we're taking and we're heating that panel, we should use some sort of a heat indicator, whether it's crayons or a non-contact digital thermometer. Ooh, but there's a twist to that non-contact digital thermometer. Aluminum, especially if it's bare aluminum, it has emissivity characteristics, which essentially means that the temperature color emitted by that shiny metal tends to not be read correctly by a lot of the non-contact digital thermometers. Some of your higher-end non-contact digitals, you can calibrate the emissivity and do a correction on the emissivity. Would be procedures that would come with that particular non-contact digital. We find that the heat crayons work very, very well whenever we're dealing with heating of aluminum. So again, make sure you've got the documentation supporting the allowance of heat on that part. Understand that heat will tend to encourage the part to be more cooperative. It is not going to guarantee success. Also understand that aluminum does not discolor. The best description I can give you of what happens with aluminum whenever you heat it to the melting point is if it's a piece of bare aluminum, right about the time it's about to drop on your shoe, and hopefully you're wearing good shoes that it's not going to burn through and set your sock on fire and burn your toes. It looks about like a glazed donut right before it hits the floor. So it doesn't discolor, it doesn't turn red or anything else. It just kind of the surface looks like a glazed donut right before it disappears, and then you got a mess on your hands. So hopefully that doesn't happen to you. Don't heat it that far. Aluminum has what they call an annealing temperature, which starts at about 650 to about 750 degrees, depending on the particular alloy of aluminum. And so that's the temperature at which you've permanently altered the molecular structure of that aluminum. You've essentially allowed those molecules to reflow and redistribute and totally destroyed the strength characteristics of that part. So that's enough about heat for right now. We're going to head on forward over to damage analysis. Yes, damage analysis is a little bit different on these vehicles. Again, we need to think about the amount of rivet bonding that the vehicle manufacturers are putting into these vehicles, and what that means about the rigidity of the joints in these vehicles. If there's any welded joints on the aluminum structure, which some vehicle manufacturers may have some welded joints, think about the stress put on the welded joints as compared to the adjacent parts whenever energy is being transferred through that. So it really opens us up to greater inspection of the joining areas of the vehicle, not just the structural parts themselves, but the joining areas where all these parts come together to try to identify, okay, is there a compromise in there? You'll find that in some cases vehicle manufacturers will have limitations on the allowable repair tolerance range. You know, if damage is beyond a certain amount of millimeters out of specification, they may flat out say, don't repair that part, replace it. And it's because they know what happens with that energy that's going into this vehicle. And if that part has moved a certain amount, then you pull it back. Well, what has really happened to those joining areas further back in that part? Is it really back where it belongs? Is the structural integrity really back where it needs to be in all the joining areas adjacent to that part? So as we're looking at damage analysis, you're looking for a lot of the same types of damage that you've looked at on steel vehicles for many, many years. Again, just looking at and taking into consideration the characteristics of some of these different parts. If you had an extruded rail that went into a large cast piece, and that's representative of the Stingray Corvette today. The 2014 Stingray Corvette has a large extrusion as the front rail, then it goes into a very large casting that then goes down the firewall area and joins into the side rail that's another extrusion. And so that casting is going to tend to be very rigid. The extrusion up front is going to tend to be the sacrificial component taking that collision energy, but still we need to look at the welds as they join to the casting, look at the integrity of the casting. You may find situations where dye penetrant is on your list of things to do as you're doing some damage analysis and during repairs for inspection of that structure. Measuring will be as critical as ever. I have to have a lot of respect for all of the vehicle manufacturers across the board, steel, aluminum, and whatever the composition may be. We've seen tolerances tighten down so much over the past years on these vehicles that measuring vehicles three-dimensionally is absolutely critical. Unless we're talking about just a minor dent in the fender or a dent in a quarter panel or something like that. If we've got something that goes into the structure and we've got structural movement, the only way to really know where all that energy went on today's vehicles is to measure those vehicles. We're finding that the telltale signs, the visual indicators of the past, they aren't as prominent, and again, we tend to use some of the same visual indicators on the aluminum structured vehicles. There's a lot that we don't know about what's the future going to hold with this new kid on the block. So far as crash performance, it's been crash tested. It's done very, very well. So we're anticipating some of the similar signs and techniques that we've used in the past, but again, measuring will be critical. Straightening. When it comes to straightening of aluminum, we really need to, again, step back and identify first, is there a vehicle manufacturer policy statement or procedural statement that says yes or no about straightening a particular part component of a vehicle? From a generic stance, your cosmetic panels, generally you can do some repairs to your cosmetic panels. Your structural components that are perhaps pushed out of tolerance, out of dimension a little bit, you may have some success in pulling them back into alignment. On many of your structural components, though, where you have any type of real major bending and deformation and buckling, you're probably not going to see a lot of success in straightening that. Again, this is an area where you're going to have to take one step at a time. Let's pull it, let's see what happens, and then let's take and identify what is the next step at that point in time. There are some folks out there that have some experience working on the Audis and the Jaguars and things like that, that know some of the, I want to say, limits of repairability. There's going to be a time in the future where many of us are going to have to get ready to wade into those as well and get more comfortable with it whenever that new kid shows up in your shop. So again, the straightening and limits of repairability are a little bit different from what we've seen with steel in the past. As we're pulling, we also have to, again, look at, if we're pulling on an outer panel, what's happening with those flanges in there, the rivet bonded areas, and the internal reinforcements that are in there. How do we know what's happened with the damage to those, or if they're damaged or not? Drilling, cutting, and grinding. To a certain degree, working with aluminum is easier than working with steel. Cuts easier, it grinds easier, and it drills easier if you have the right tools and use the right techniques. The lower picture shows a rotary carbide burr. It's a very aggressive one. It is not the same as they use on steel. These are specially designed for aluminum, and they won't clog. Whenever you're drilling, now it depends on what you're drilling. Are you drilling the rivets? Are you drilling the aluminum? If you're drilling steel rivets out, you're going to want to make sure you're collecting the dust, the debris. Best to have some sort of a dust extraction system there that's explosion proof in order to collect up that debris. That way you're not creating cross-contamination there. Some vehicle manufacturers actually recommend what looks like a wax block to lubricate some of our cutting tools, but you're going to find that aluminum is much more cooperative whenever it comes to using I'm going to say like a reciprocating saw or something like that cuts very, very easily. Now, on the other side of that, whenever you're grinding it, if you're using a grinding wheel, make sure you have a grinding wheel that's designed for aluminum. Your traditional cutoff wheels and grinding discs for steel, if you use them on aluminum, they'll tend to clog up very, very quickly, and at that point in time, they become pretty worthless. While I'm speaking of that, you should make sure that all of your tools, cutting, drilling, grinding, whatever it happens to be, that they are dedicated to aluminum, cleaned up very, very well. For the most part, you can probably still use that air drill that you use on steel. Just clean it up. Make sure you're not taking a bunch of steel debris with you whenever you go over there. Make sure your drill bits are clean and in good shape. Let's face it, the drill bits are going to be made of steel, but we want to make sure they're clean. You want to make sure you're not cross-contaminating with grinding discs. Sanding. Whenever you've got sandpaper on a DA, you really don't want to use sandpaper that's been on steel and go over to aluminum and vice versa. That's just a bad combination there. We make sure we've got fresh, clean, abrasive materials so we're not cross-contaminating. Part attachment. Let's take a quick peek at part attachment at the OEM level. They can bolt them, they can rivet them, they can weld them, they can use clinches, they can use little guys like called EOTs, which are flow drill screws, combination of different things, and with some of those different attachment methods, they've got adhesive in there and others they don't. It's up to them how they do it. As we take a look at repairing the vehicle, we're gonna find that rivets come into play quite a bit moving forward. We may have some bolts, we may have some EOTs. We're going to find that adhesives come into play quite a bit in the repair of these vehicles. And welding on some procedures, perhaps. That's something that, again, is going to be a little bit of a learning curve for some of us, but certainly attainable if you're a proficient welder. So let's take a quick peek at a clinch. A clinch is kind of like the tab on an aluminum soda can, where they use a die and a press to take and draw the metal through itself. We see it on a lot of hoods and deck lids and some of the fenders out there on attachment brackets. It tends to be a non-structural attachment that the vehicle manufacturers use. This is something that we have no way of replicating directly in the repair process. Generally, whenever we see a clinch, if it's damaged, if it needs to be somehow replaced, it's typically replaced with a rivet, and in many cases there's some adhesive that comes into play with that as well. So that takes care of the clinches. Bolts. As we get into aluminum vehicle structures and parts more, we're going to see that we have specially coated bolts. The coatings used on many of these bolts is baked on in a special manufacturing process at high temperature. It is not a coating we can directly replicate with some stuff in a can with a brush. Now, if there's something out there that we haven't learned about, we'd love to know about it, but we'd like to see that whatever that material is has an OEM endorsement, recommendation behind it in order to be truly validated in its application. So the bolts have these coatings on there to help minimize galvanic corrosion issues. If the coatings on the bolts are damaged, typically those bolts need to be replaced. Rivets. This tends to be the piece that most folks are getting, I'm going to say, a little nervous about. I wouldn't get too nervous about it. What it's going to take is us doing our homework in advance. Whenever we start looking at the repairs of these vehicles, you may find that the vehicle manufacturer has a number of different options, different types of rivets they may allow to put that vehicle back together. So I'm not saying that's going to hold true in every situation and every vehicle make out there. In some cases, they have very unique requirements where this is the only rivet that goes in that particular location. So again, we need to do our homework whenever it comes time to repair this to see what's the option going to be for this particular vehicle. Now, a few of these tools you're only going to get through the vehicle manufacturer so far as the dies go and things like that. In other cases, we're finding where some of these tools are becoming more widely available to the industry. As you take and you evaluate the vehicles you're working on, that's going to take and really dictate which of these tools do I need. So you really need to look at what parts are being replaced on the vehicle, what are the OEM part replacement requirements, what types of rivets are required to put in there, then look at, okay, which tools do I need to put this vehicle back together. Now we've got self-piercing rivets, which is the rivet on the left in the photo. We've got full rivets, which is kind of the rivet standing up on its countersunk head there in the middle. Then we've got some of the blind rivets, the two on the right-hand side of that particular photo. and a variety of different rivet tools above there. As we take a look at self-piercing rivets, self-piercing rivets are used by the vehicle manufacturers as they put many of these vehicles together, and they'll have adhesives typically between the flanges on these vehicles whenever they build these vehicles, and they take and they press that rivet right in. They've got these huge robotic insertion tools at the factory that can reach all over that vehicle and basically punch these rivets right in. They do not protrude through the back side of the panel. So whenever that rivet's in there, it's actually a coated steel rivet that goes in and it flares out, and it joins the two pieces of metal together. It takes a special press tool to put it in. There's a variety of different ways to get them out. Vehicle manufacturers may have specific recommendations or requirements on removal tools. It can vary from drilling them out to grinding the backside away and then punching them out to using a special press tool with the right dies in it to take and press the rivets out. One vehicle manufacturer even has a special stud gun that will weld a stud on the top of it, and then you've got an extraction tool that then takes and pulls that rivet out. So again, this is something that we'll need to get comfortable with because we will see these on the new vehicle coming down the line. Bonding preparation. As we're preparing panels to be bonded, again, this is an area where we should look at the specific service information for the vehicle we're working on. And I can't reinforce that we have the current, most up-to-date information. A lot of times folks will ask me for information at an ICAR class. I taught plenty of ICAR classes over the years, and certainly encourage you all to attend the FOR 06 course coming up in June. The question that comes to me during class, well, Jeff, you know, can you tell me about this procedure? Well, yes, I can tell you about a procedure, but a year down the line, there may have been changes to that procedure. So it's really important that we do look at that latest and greatest service information, that we get that information and we apply it to that particular repair so we know we're doing it right today, not based on, I want to say, some dated information. So bonding preparation. Again, different vehicle manufacturers may have different flange preparation requirements. In most cases, whenever we're bonding and riveting aluminum, we're going down to the bare metal surface. Now, that's not 100% true across the board on every panel on the vehicle, but most of the time, that's what holds true. Again, the key here is identify what's required by the vehicle manufacturer you're working on. There might be a flame treatment process with an adhesion promoter that goes on. There might be a silicate stone process with an adhesion promoter or something of that nature. It's really a case-by-case basis. Whenever it comes to welding aluminum, it has to be clean, clean, clean. This is an area where practicing on the vehicle is not an option. Whenever you go to the vehicle, you're not practicing. You are welding the parts onto that vehicle, and you need to be successful as you go across there the first time making that pass. Otherwise, you're going to have some scrap metal on your hands. It's not very pretty. So it is absolutely critical when we're dealing with welding aluminum that, number one, we have the correct electrode wire identified. There are many different alloys of electrode wire out there. That we have the equipment that then can take and facilitate that weld. You may find that some manufacturers specify certain equipment. In other cases, they may just specify that it is a pulse-capable welder. And there are many fine welder manufacturers out there manufacturing equipment today that put out pulse-capable welders. It's certainly something, though, that as technicians, especially the technicians out there that are going to do the welding on these vehicles, that we spend some time practicing and getting proficient with the welding process before we go pulling an arc on that vehicle and perhaps ending up with a less than desired outcome. We will find that there are some welding procedures on many of the aluminum structured vehicles out there for some of the partial replacement or sectioning procedures of parts. So we will need to have some proficiency there. Welding is a little more challenging. Depends on your aptitude as a technician. If you're a really good welder of steel, you can generally transition over and start to weld aluminum pretty quickly. It does weld a little bit differently. You tend to have to vary your technique because of the heat propagation in the aluminum. It doesn't tend to allow you to read the panel as easily for whenever it's going to melt through or burn through. So again, getting your equipment tuned up and getting your technique right before you go welding on the vehicle, again, absolutely critical. Argon shielding gas. 100% argon shielding gas is the requirement whenever you're dealing with welding of aluminum. Whenever you're sanding any parts and prepping flanges and things like that, about the most aggressive you should get with your sanding grits is about 80 grit or finer. You may have weld nuggets and things you're taking away. You might look at something a little more aggressive for weld nuggets you're taking away and things of that nature, but again, you're not trying to thin the flange out. You're just trying to remove any unnecessary material that's there. ICAR developed the 2015 Ford F-150 structural repair training course in conjunction with Ford. We contracted with Ford on this particular project. We were under non-disclosure for a little over 2 years, I think it was, as this was being developed. The course takes a look at some of the cosmetic aspects and some of the structural aspects of the repair of the vehicle, generic aluminum repairs, and it gives you an understanding of aluminum characteristics. The course is really designed to help the industry get comfortable with what's coming. The course is not designed to replace the service information that you'll need whenever you get one of these vehicles into the shop and start working on it. So this course will be available in June. Its course code is FOR06. You can actually probably look up on the ICAR website and see where there's courses available in your particular neck of the woods. Platinum, Road to Gold, and Gold class. Platinum is for the individual technician out there. A lot of technicians out there have attended ICAR training and show that proudly by obtaining the Platinum designation. Gold class is a business designation. We have a number of Gold class shops out there in the industry. Congratulations to all of you that have attained Gold class and maintained Gold class. And then there's folks out there that are working towards Gold class. We call that the Road to Gold. It takes a tremendous amount of dedication on the part of the technicians in the shops and the businesses out there in general, because I can't exclude that there are insurance companies out there that are Gold class as well. So congratulations to all of you. If you have more questions about Platinum, Road to Gold, or Gold class, I'd encourage you to get in touch with the ICAR customer care team. And that's the ICAR web address up there, icar.com, i-car.com. Customer care team, 800-422-7872. I believe Melissa was a little concerned about me running long, and I think I've given a few minutes here for Q&A right at the end. So if we've got anything there, Melissa, I'll certainly entertain.
Does anybody have any questions? I'm not getting any. I had a...
Uh-oh, I seem to be having some technical difficulties here myself, so sorry about that.
Well, if anybody has any questions to ask Jeff, you can type them in your chat box, and we'll let them know what they are.
There we go. I think one of the questions that that's come up is with the new vehicle coming down the line, there's a lot of concerns about shops being able to repair that. I just want to speak to Ford. Put a tremendous amount of effort into designing, engineering, and building this new vehicle so that while it is going to take some tools and equipment to repair it that perhaps some folks don't have, they haven't made it impossible. They've made it attainable. And I look at this vehicle as the beginning of tomorrow. Not this is it and this is the end. This is just the beginning. And I think about our industry and where we're headed. We're headed in a direction where corporate average fuel economy mandates are driving more of this type of construction. We're going to see it. It's going to continue. So again, my hat's off and kudos to Ford for taking the leap and putting it out there in the F-150 and for designing and engineering a vehicle that has some very unique and interesting repair procedures that in many cases are easier to do than the predecessor steel platform vehicle. And I'll make one more comment. The frame is still steel in the vehicle.
Okay, I do have a question here.
Yep.
All right, what do you, let's see, what is the average cost to prepare a shop to repair aluminum?
It's a big investment. That's all I'm going to say. I can't speak to the direct cost of anything. Working with ICAR, that's one of our off-limit topics so far as cost of tools and equipment and things like that. I will say that it is a substantial investment. Do your homework carefully before you start investing. That way you strategically make the right investments.
Okay, FOR06 class opens when in June?
going to open up June 2nd. I think June 1st is a Sunday, so I believe we'll start seeing ICAR classes open to the industry. If you go on the ICAR website, you should start to see some classes in there. They're probably on the schedule right now. I can actually navigate in really quick here if I just jump right over to the ICAR webpage and jump in here, and all I have to do is choose a class. If I go in here and I scroll down to, let's see if I can move this control panel out of my way real quick here, and scroll down to FOR06, and if I go down here and I'm going to put in my home zip code, which is in Maryland, right outside of DC, and I'm going to take and click in search on that, and let's see what comes up on the public search schedule of classes. Well, okay, it's thinking about it. Think about it faster. There we go. So there's a number of, if you were in the Silver Spring, Maryland market area, you'd find that there are a number of FOR06 classes available that folks out in the industry could register for all around Maryland. And it's really that easy to go to the ICAR website, select the course you're looking for, put in your zip code, and see what's available. I do encourage you to pre-register and prepay online for those. We are finding that we've had some pretty fantastic response to this course, and some of the classroom settings are filling to capacity and selling out pretty quick.
Any other questions? I haven't seen any. Okay, I'm not seeing any more questions. That concludes our webinar. We hope you found this informative, and we'll be in touch with future training opportunities. Thank you, everyone. And oh wait, I have another question. Can you let's see? Can you spend more? Something more about the need for explosive-proof vacuum systems and how achieving aluminum certification?
Okay, yeah. So explosion-proof vacuum system, the dust collection systems. That's an area where it's not just a vacuum cleaner. It's a very unique dust collection system for aluminum. Aluminum in the correct concentrations with other elements can become explosive. For some reason, they won't tell me exactly what that is because they're afraid I'm going to blow up the shop. I'm not sure, but essentially what it comes down to is, yes, there are some very specific requirements for a dust extraction system that is designed for use specifically with aluminum and other typical elements that we're going to find associated with our repair process. So anytime you're out there checking out these dust collection systems, make sure that it is explosion proof and that is rated to be used with aluminum. I know some of them actually have kind of a water bath filtration system in them to take and I want to say cleanse the air and cleanse the filters and eliminate any potential for a bad day at the office. It's not the shop built-in central vac system. That's really what I want to impress upon folks. I know some shops have a built-in central vac system for collecting body filler dust and things like that. That is not a good idea to try to adapt that over. You may find that you have a really bad day at the office out back where the main vacuum motor is.
Okay. Any other questions? I'll wait a sec because it takes a second for them to come over. Okay, I think I'm not getting any. Again, we'll let you know about any future training opportunities, and we really appreciate you all attending this webinar and hope you found it informative. Thank you.
Thank you, Melissa. Appreciate your support and Impact Collision Solutions support.
Great. Thanks, Jeff. Bye, everyone.